What's up, guys? In this video, what I want to do is tackle 3 problems that you absolutely have to know to truly understand combining rational expressions. So these are not the easiest, but they're definitely not the most difficult you should expect to see on a test and a quiz or some sort of an assessment to be able to make sure you understand how to combine rational expressions as well as not to make any mistakes. And what sets these 3 problems apart is they start to involve factoring. And that's where a lot of students' understanding starts to break down. If it wasn't bad enough adding and subtracting fractions, once we include factoring, a lot of students' understanding just goes out the window. So one of the main things we've talked about when adding and subtracting rational expressions has been you have to get the common denominator. The fastest and easiest way to be able to find the common denominator was to always just multiply your 2 denominators when you're dealing with polynomials. But again, there's a caveat to that. I said when you could not simplify them. Sometimes you have denominators that are actually going to be shared. And a quick little example of this is, again, let's just kind of go back to our fractions. What if I had a 1/2 plus a 1/6? The smallest number that they both share is not going to be 12, right? If you kind of list out the multiples of 2, so 2, 4, 6, 8, 10, 12, and then you list out the multiples of 6, you do 6, 12, 18. What I want you to understand, the smallest number that they both divide into, right? The least common multiple of them is going to be 6. How do we know when to multiply denominators or when we only need to multiply one denominator to get the other? And again, it really just kind of comes into when we can break down our denominator. Now, typically we don't go ahead and do this with our numbers, but since 6 is a composite number, we can go ahead and break this down into 2 times 3. So therefore what that shows us is, oh yeah, to get a common denominator, I just need to multiply my left-hand side by a 3 on the top and the bottom. Now, when we're dealing with polynomials, it's kind of the exact same idea. I can't do anything with an x plus 3. However, with an x squared minus 9, I can actually break that down, right? I can actually simplify that to an x minus 3 times an x plus 3. Because the one thing I recognize is that is the difference of 2 squares, right? So when you recognize a trinomial that can be factored, then factor it. So what I'm gonna do is I'm just gonna put an x through here because I don't want you to be confused with having 2 different denominators. This is gonna be my new denominator. So if I wanna add this fraction, a 5x over a x minus 3 times x plus 3 to the fraction 2 over x plus 3, the only thing I need to do to get common denominators is to multiply this by an x minus 3. So I'm going to do that on the top as well as on the bottom. So now I have 2 fractions, right, with the exact same denominators. Now remember, all we simply need to do is just go ahead and combine your numerators. Up here, the first thing I want to do here is again simplify this. So again, I'm going to apply my distributive property. Okay, so when I applied my distributive property, I got a 2x minus 6, right? And again, everything's going to be over my common denominator, which again, I'm just going to leave in factored form. You could multiply back out to an x squared minus 9 if you really wanted to. But again, we never know if something might be able to be simplified out. So therefore, I'm going to leave it just as is. Now I can add the 5x and the 2x, so that's going to give me a 7x minus 6 all over a x minus 3 times an x plus 3. And nothing can be really simplified out from here. So therefore, I'm going to leave that as my simplified answer. All right, now in this next example, hopefully you recognize whenever you see a quadratic trinomial, there should be like some sirens going off in your head that's saying ding, 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 like factor, factor, factor. Like it's one of the dead giveaways that you need to know when you are trying to simplify or combine an expression and you see a quadratic. Always look to see if it is factorable. That's why it comes into your familiarity and your understanding of factoring. It can become so helpful for you to understand how to factor something quickly. Not all the time are we going to want or need to be factoring, but in problems like this, it's especially important. So there's really nothing I can do here for the x minus 4. And again, like if you think about the whole idea of the LCD, like, do I really want to multiply an x minus 4 times this expression to get some random multiply that would have the common denominator? No, right? What I want to do is be able to say, all right, I have a quadratic, like how can I factor this? Now, this was not a difference of 2 squares where it was a quadratic binomial, but there is some similarities here because in a difference of 2 squares, your first and your last number are both square numbers, right? If you look back at the last example I had, this was an x squared, which is squared, right? X times x, and this was a 9 squared, which is a 9, which is a square number, 3 times 3. So whenever you have that similar relationship, but as a trinomial, think of your perfect square trinomials. And basically what that means is going to be a binomial multiplied by itself. Now, we could also go through our typical understanding of factoring, like you could use the x process. There's a lot of different techniques to understand for factoring, but basically a quick little way to summarize is what 2 numbers multiply to give you 16, add to give you -8. Now, if this was a perfect square trinomial, that number has to be the same. That kind of tells me, oh, this problem is going to be a lot easier because 16, there's a lot of numbers that multiply to give me 16, right? 16 times 1, 8 times 2, 4 times 4. If that number has to be exactly the same, the only one that would work would be 4 times 4. However, 4 times 4 does not give me a -8, but -4 times -4 does. And -4 times -4 also gives me a 16. So what I can do is I can actually rewrite this as a x minus 4 times an x minus 4. Now we can go ahead and cross this out, right? It's not going to be needed this time. We have this as our denominator. And you recognize that these are very similar. This has x minus 4 and x minus 4, and this only has one x minus 4. So even though they both share an x minus 4, This has 2 of them, this only has 1 of them. So for us to get a common denominator, then I need to multiply this right-hand side by an x minus 4. So I'll go ahead and do that on the top as well as on the denominator. And then again, just notice here, I have a binomial. So therefore I'm going to put that in parentheses just to make sure that I'm applying the distributive property. Now, another thing that I always like to do, and this is like a nice little trick, whenever you're subtracting, right? And when you only had like 1 number, it was perfectly fine. But when you have like multiple numbers, it's probably really helpful just to rewrite it as an addition problem. So what I mean by that, if I had like 1 minus 3, I think we know that answer is going to be a -2, right? Well, any subtraction problem, you can always write as an addition problem. So what I could do here is I could say 1 plus a -3, right? That's really the same thing. 1 plus -3 is going to equal a -2. So what I'm simply going to do here is when you change that to a negative, when you change a subtraction problem to an addition problem, what you're doing is you're changing the sign, but you're negating the number. I'm just going to go ahead and put a plus here and then a minus there just to represent. And I'm going to use red just for you to recognize that I am adding those in there. Okay, now that we have our common denominators, we can just go ahead and combine our numerators. But before we do that, again, we have to apply the distributive property, right? So I need to make sure I'm multiplying a -12x now to both of these terms. And then I'll write them all over my common denominator. Okay, now it might look a little weird to say an x plus a -12, but again, we can just go and combine those. But the main mistake students will make is not really with the x minus the 12, but a lot of students will just multiply a 12x minus a 4 and get a -48. So that's why I think it's really important to make sure you have that negative sign right next to your number when you're doing the multiplication. Otherwise, you're very prone to make that common mistake. So now I can just go ahead and simplify my numerator, right? X plus a -12x or x minus 12 is just going to be a -11x. And then the way that you could simplify your denominator, you could leave it in this factored form, or you could also write it as a binomial squared, right? We could just write this as a x minus 4 quantity squared. Now, in this example, you can see again, we have a quadratic trinomial. So I'm immediately going to go ahead and look at that one to say, all right, I'm just going to go ahead and factor this. I'm not even going to worry right now about what the problem is. I just know, can I factor this? And again, when we're looking at this, we want to say what 2 numbers multiply to give me 3, but then an add are going to give me a -4. 3 is not a square number, right? So we're not looking for that perfect square trinomial like we did in the last example, but we want to look to the factors of 3. And thankfully, the factors of 3 are only 3 and 1. So for them to add to a -4, it has to be a -3 and a -1. So I can just go ahead and quickly factor this as an x minus 3 times an x minus 1, and I'll go ahead and put a line through that. All right, now we have an issue, because I have x minus 3 and x minus 1 on the right-hand side, but over here I have a 2x minus 2. Now, sometimes you will encounter problems where you're going to have 3 different denominators and you're going to have to multiply everything by that LCD. But that is going to be a pretty difficult problem and kind of definitely more of a challenge. And in this video, I want to just focus on problems that you definitely need to know, not trying to just overcomplicate things. So when I look at this left-hand side, what I recognize is there anything else I can do to simplify this? I can't factor like it's a quadratic. However, I do recognize that both these expressions share a 2. So I can factor out our greatest common factor, which in this case, again, is 2. So by doing that, I get a 2 times an x minus 1. And now you can see that they both share an x minus 1. Therefore, getting common denominators is not going to be as difficult. However, there is a little bit more that we need to do, because on this left-hand side, we have a 2 and an x minus 1. And here on the right-hand side, we have an x minus 3 times an x minus 1. So on the left-hand side, we have a 2, but this one we do not have a 2. So again, I'm going to write a 2 on the top and the bottom. Now again, since I'm multiplying this 2, we have this binomial expression. I'm going to go ahead and use my parentheses. On the left-hand side, I already have an x minus 1, I already have 2. I just need the x minus 3. So I'm going to put a x minus 3 on the top as well as on the bottom. And again, since this is another expression, I'm going to go ahead and put this in parentheses. Now again, remember this is a subtraction problem, so you can go ahead and change this to an addition problem and making this negative, but sometimes it might be confusing with everything we have going on. So what I'm actually going to do is I'm just going to go ahead and rewrite the expression over my common denominator. You can see that it makes a little bit more sense here to put the 2 in front, right? So we recognize it as a negative, and just to write everything over my common denominator. And there's nothing wrong with changing this to a plus and negative, but again, I think sometimes that can be confusing as well. Just a lot of times when you're dealing with multiple parts, there's nothing wrong with just going slow and rewriting everything so it's in a nice clean version. And if you don't have room on your paper, then just go ahead and get a scratch piece of paper and go ahead and do that. Now, on the exact same thing with simplifying this, we have a lot that's going on, right? We have a binomial times a binomial, and we have this -2 times the 2x minus 1. So again, I'm just going to kind of show all of my work by multiplying this. I'm going to go ahead and use FOIL, which basically is just another way to remember distributive property, because when you're multiplying a binomial times a binomial, you need to multiply every single term times every single term. And when I do it over here on the right-hand side, just remember this 2 is negative. So, all right, so let's go ahead and work this out step by step. So x times x is going to be a x squared. X times 2 is going to be a 2x. 3 times x is going to be a 3x, and 3 times 2 is going to be a positive 6. Now here, I'm just making sure that I'm keeping this negative with the 2. So negative 2 times a 2x is going to be a negative 4x, and negative 2 times a negative 1 is going to be a positive 2. Now again, this is all over my common denominator. And you want to make sure whenever you're doing this, so you're just writing it all out. I know it just takes a quick little second, but it is important to kind of keep everything together. Now I can't combine anything with my x squared, but I do have multiple terms with only an x, right? And then I have 2 terms with my number. So therefore my final answer is now going to be a x squared. 2x plus 3x is 5x, minus a 4x is going to be a positive x, and then 6 plus 2 is going to be a positive 8, and that's going to be all over my common denominator of 2 times x minus 3 times an x minus 1. Nothing really. I can simplify my numerator. You could multiply your denominator if you need to, but hopefully if you got this answer, then you are all on your way. Now, these 3 examples were designed to help you pass your test or your quiz. But if you're looking to get the top grade and really have a deep understanding of combining rational expressions, well, check out the next video where I reserve only for those students looking for the A. And if you're not ready for that, no worries. If you just want some more examples of combining rational expressions, or you want to take a look at the notes that I offer inside of my course, then go ahead and check out the examples I have for you down below. I'll see you guys in the next video. Cheers.